Welcome to solverfy.
Okay, so we're doing chapter 22, problem 39 here. So it says a non-conducting sphere of radius r naught is uniformly charged with charge density rho e. It is surrounded by a concentric metal conducting spherical shell of inner radius r1, outer radius r2, which carries a net charge of positive q. We want to determine the resulting electric field in the different regions. Okay, so let's go ahead and draw this out. So we have a sphere of radius r naught, and this is non-conducting, uniformly charged with rho e. Outside of this, we have another spherical shell with a small radius r1, big radius r2, and it has a total charge q. So q equals q in plus q out because it's conducting, so we can only have charge at the surfaces, the inner and the outer surface. Okay, part A asks us, we want to figure out the field for r less than r naught. Well, immediately, we got to figure out how much charge is enclosed. So we draw a Gaussian surface, and we know that from the Gaussian sphere, the electric field is given as how much charge is enclosed over 4 pi epsilon naught r squared. So Q enclosed for r less than r naught is given by the charge density times how much volume we've gotten through so far. Cool. So if we plug that into our equation right here, we see that E now equals rho E R over 3 epsilon naught. Awesome. Part B. This is for R is greater than R naught, but less than R1. Okay. So the enclosed charge in this case is just all of the charge included in the small sphere. So if we draw this out here, we're not including any of the charge from the conductor yet. So Q enclosed is rho E times 4/3 pi r naught cubed. Plug that into our equation for the electric field, and we're left with rho E r naught cubed over 3 epsilon naught r squared. Cool. Now let's move on to part C. So this is for R greater than R1, but less than R2. And this puts us inside of the conductor, so we don't even have to do anything. We automatically know that the electric field is 0. Part D finally asks us, though, for R greater than R2. So now our total enclosed charge is Q from the conductor plus however much was enclosed in our small sphere. So that's the total in charge enclosed. So our electric field now becomes Q plus rho E times 4/3 pi r naught cubed all over 4 pi epsilon naught r squared. Or if we want to simplify this a little bit, we can write Q over 4 pi epsilon naught plus rho E r naught cubed over 3 epsilon naught all times 1 over r squared. Cool. And that's it for this problem.